Hold on, super loud and I don't. Zoom totally up the volume on its own. That's so mean.
Yeah.
Sorry,
All
guys.
of these programs think they're doing you some kind of favor by managing the volume, and they're not.
No, it was terrible.
Yeah. Yeah, it's unacceptable.
Yeah.
It's a war crime, I think. Crime against humanity.
I agree.
Yeah, your ears hurt.
And so does my chats. I'm sorry, chat. Everybody's like, geez. Look at their faces.
Yeah.
Nailed it again. I know, it does it all the time, though. It's so annoying. But yeah, they think that they're helping, but they're not. Look at, there's two Frasers.
Oh, this guy. Oh.
Fraserception, guys. Yeah. Okay, so let me make these more appropriate. That's the other thing. It never saves it. With Discord, it was actually starting to save the
background picture.
It was starting to save like the image, captured image. But just so you're not uncomfortable, we'll go ahead and I'm just gonna open up. Yeah, because I'm gonna open up your YouTube here because I want to watch the rest of that Q&A. This is his YouTube, guys. This is where you get good information.
Oh, thank you.
Yeah, no clickbait stuff. I mean, he has good titles for clickbait, but it's actually not clickbait.
I was so proud of my title for Universe Today for the moon plant story. I said, "There's life on the moon." That we sent there.
Exactly.
Oh, the book holster is not ready to deploy. I have failed in I cleaned up my desk and I put my book away. I'm the worst.
Let's see. So there was questions already coming in. So guys, this is Fraser Cain. He is the publisher of Universe Today. He's the owner of all of that. Also Astronomy Cast. If you guys have heard of Astronomy Cast, it is a wonderful podcast with him and Dr. Pamela Gay. And
you want to see our new dog?
Yeah, she has a new puppy.
Yeah. Well, not exactly a puppy. Let's see if I can get her attention.
Oh, are you watching said puppy?
Over here. So nope. Carla's here. What?
Okay.
So,
oh, that's your new dog.
Yeah.
Why is everybody getting new dogs?
It's Carla's new dog. Oh.
Oh.
Yeah. So her name's Ona, and she is she's an English Bull Terrier, and she is a rescue. So we got her from Washington. We drove down and got her from Washington State, and she's deaf, so she can't hear at all. And we've tried, and yeah, there's no hearing at all. So it's very weird dealing with a deaf dog. But she's an absolute sweetheart, total cuddler. And we don't know how old she is, maybe 3 to 4 years old. So, and she's actually quite small for bull terriers. So,
yeah,
the dog is never going to listen. So theoretically, we can. Oh, you want that? Do you want that snack right there? No. Okay. All right, I'm going to put her back down. Oh, that was a little invasive. Okay.
Oh, Ona is her name, Joe. Yeah, I know he was away from the mic. The name is Ona.
Yeah, the dog is never going to listen.
Yeah,
like a dog. And so it does create a bit of a challenge. Like, we haven't gotten to this point yet, but like if you take your dog out to like a park and the dog's off leash, the dog's running around, then you can't summon the dog back, right?
Mm-hmm.
So apparently there is technology out there. There's like a thing that will buzz, and you can teach the dog that the buzz is happening, and then you can. Then it knows to come back and pay attention to you. But it's also very strange too. You're walking down the street and the dog is constantly shoulder checking because she can't hear us walking with her. So
right.
She keeps turning back to make sure that all of her pack is with her. So it's great though. Cute dog.
Yeah. When did you get her?
We got her about a week and a half ago. Yeah.
Oh wow.
Yeah, so we were in your country about not last weekend, but the weekend before that.
Wow. Yeah, she's pretty. She's really pretty.
Yeah, she's really cute.
Everybody's getting. I thought you were talking about Dr. Pamela's dog.
No.
Everybody's getting dogs.
Yeah, well, Carla is a super dog nerd and has had dogs all her life, and and her dream dog has always been bull terrier. So we had our previous dog, Chuck, and she passed away back in October, and
Right. I
so
remember
then
that.
it's been kind of sad since then. And but Carly needed some time to grieve and kind of get through that process, and now it's time for more dog.
Yeah. It's funny because my dad, he always gets new dogs. He gets a lot of rescues too. And he always be like, I'm never getting a new dog, like after they pass on.
Yeah,
And then he goes and gets another one.
yeah. Well, it's tough, right? Because there was a cartoon, I forget what it was, like a meme or something like that, where it's just like, yeah, do I want to get a dog and know in 11 years to have heartbreak?
Right.
Right? I mean, that's the downside, is that we live longer than them, and they find this place in our hearts, and then we go through this grief, and we go through it again and again and again every as they age and pass away. But at the same time, you have so much fun when you have the dog. So it's tough. It's a really tough dilemma. And obviously there are the downsides of being able to like go out and travel, and you have to have someone take care of the dog. But
Yeah,
with it.
Tesla says he knows a search and rescue dog that uses a buzz collar.
Oh, cool. Yeah, yeah. So that's the kind of thing that we're thinking of. That's right. So the dog is completely out of sight, and the dog can come back. That's really cool.
Yeah.
Yeah.
That's pretty amazing. But people were already asking questions.
Let's do
First,
it.
first though, are we thinking star party this Saturday?
Saturday. Well, so maybe. So the problem here is uh folks in Los Angeles know that it's raining. It's been pouring rain in LA in where the telescope is. So the
What about the one in? Because I did talk to Dustin. And he said if you guys want to use the one in Texas too, you
Yeah,
know.
so the weather forecast right now looks like it's rain today, cloudy on Saturday, and cloudy on Sunday. So I think the Joshua Tree one is out for all the way past the eclipse.
But the Texas one, he was saying if you
Yeah.
guys, he's
So
like you
the
guys have
Texas
access to
one,
those.
let's see what their weather is. Saturday is sunny, Sunday is sunny. So that'll be the one.
Yeah,
We'll give it a try.
yeah. Would you guys like to see? Because I know a lot of people have been. We haven't done one in a
Mm-hmm.
while, and
Yeah, yeah, yeah.
we should
Yeah, there
make
are winter
this.
constellations now and winter
Yeah,
objects. We should take some pictures of them.
yeah. Like
This,
Orion.
yeah. So
I know.
this telescope is a little different though. So it has a different profile. The way it takes images, the the length of exposures that I have to do. So I'm still learning how to use it. It has narrow field. We talked about this last week. Right? It has narrow
Mhm.
field filters and stuff. So yeah, as long as people want to see me struggle with a new piece of technology, then
Oh,
yeah, let's
yeah.
totally do it.
These guys are all for it. They see me struggle all the time. They love
Yeah,
it.
exactly. Yeah, yeah. Willing to watch how the sausage gets made. Yeah.
Yeah, exactly. So, yeah, we could plan on that. And what's nice is we can do it pretty early. We don't have to stay up super late because the
Yeah.
sun sets pretty early in the winter. So,
Yeah, there that observatory wants to be around 6:30, 7 o'clock local time for it to get dark. So that's around five. It's 2 hours ahead. So around so your time
it's only one
around
hour.
7 o'clock, right? So probably eight, just to have darker skies.
Yeah, yeah. I think
Yeah.
that'd be great. So, we
Yeah.
should plan
Okay.
on that.
And I mean, also, I want to use that as a way to prototype getting set for the eclipse on Sunday night.
Yeah, so we could do it as a total test run. That's
Yeah,
perfect.
because the moon will be at almost full awfulness. It'll be at mostly awful, and that'll be a good test.
Yeah, yeah, it'll be great. It'll be
Yeah.
perfect. And we should and I'll talk with you more about this, but we should make these more of a regular thing. I know that they would love to see that and then other people in here, but like OPT too.
Yeah, no, everybody. I know. Everybody likes a certain amount of just like predictability and a schedule that they can commit to, and they know when things are going to happen in the future.
Yeah.
And that is absolutely the reality. And at the same time, you're sort of wrestling with technology and the weather at
Right.
the same time. And that was why we had to shut down the star parties in the olden days, was just because the weather was brutal. Trying to rely on people to go out and set up their telescopes was tough. So hopefully we will get to a place where that is never a problem again.
Right.
Then the only problem is me getting sleepy
Right, right, right. Um,
as a terrible astronomer.
yeah, so we'll plan on that, guys. And yeah, so there's other questions coming in. So any idea on who was the first person to think of using a sunshade and when? So a coronagraph, I
The
think.
first time that I saw it, and I don't remember, Webster Cash. The first person that I saw that was in one of NASA's, uh, their advanced technology awards that they give out every year. That was proposed. Man, it feels like it was like close to 10 years ago. They had described the sunshade. Man, if I'm right that it was Webster Cash, I am the greatest.
You would be. I'd give you a
Yeah,
virtual high five.
yeah, yeah. Uh, was it? Did he come up with the sunshade, or did he come up with the lunar elevator? Yes, it was Webster Cash, 2005, and
Ooh.
it was done through NIAC. So, and he's out of Colorado in Boulder. You
Oh,
should go there sometime. It's a nice city, apparently.
I I should go there.
Yeah, yeah.
I live here.
Webster Cash in Boulder,
Right.
just waiting for some kind of interview to talk about sunshades.
I know there's so many people
I know.
in my area that I mean this is like an astronomy place.
Yeah.
Ooh, this is an interesting question. And I'm not sure. I mean, this both of you and I could probably maybe, but I don't know. Okay, so what would happen if a black hole passes by and grabs some of the sun's mass and leaves? What would happen to the sun? Will it explode or collapse?
Okay. I think the premise of the question is a little off, right? It's like, what would happen if you had a fly and a semi truck crashed into it? Would some of the fly be taken away? Would the fly lose a little bit
wing?
of its skin and maybe hair?
Yeah, maybe it
Right?
loses a quarter of a wing or
A
something.
quarter of a wing or something. Yeah, the semi truck side swipes it. The thing is like to get a black hole, you've got to have a star that is 15 plus times the mass of the sun. The remaining black hole is going to have many times the mass of the sun. A black hole in the solar environment is would be the most dominant feature around. We would all be orbiting this black hole. It would call the shots. It would throw the planets hither and thither. So it's more the question that you're asking, like if you just instantly took a whole bunch of mass away from the sun, would that cause the sun to explode? And
Well,
no,
mm-mm.
right? If you took away mass from the sun, you would make it live longer.
Mm-hmm.
You would be decreasing its mass, you'd be extending its life. And if you could get it down to the point that it was about 15% of the mass of the sun, then it would be a red dwarf and it would
Mm-hmm.
live for trillions of years.
Long time.
So, yeah, you'd just be rejuvenating it you think you're taking away from it, but you're really just making it last longer.
Yeah, yeah. And again, he said trillions of years. That's what we think. It's that convective fusion. It's different than what we have with our sun. Can you explain the difference between a sunshade and a coronagraph?
Sure, I can do a mediocre job of it. So both of these technologies, right? Starshade and coronagraph. The gist is that you want to block the light of the star so that you can see the planets that are orbiting around it. So our telescopes are perfectly sensitive enough to see exoplanets directly. The problem is that stars are right beside the planets. Wherever you look for planets, you keep finding stars that are way too bright. And so the strategy would be then if you could somehow block the light from the star, then you could reveal the planets that are surrounding it. But that's actually a fairly technically challenging thing to do. So there are two technologies that have been proposed to do this. One is actually in use, and this is this idea of a coronagraph. And what you're doing essentially is you are bringing the light from the star into your telescope, and then you are using constructive interference to essentially cancel out the light from the star on itself. You're blocking it, and then you're also there's sort of light that's sort of escaping around the edges, and you're blocking that light as well by having the light go through a bunch of mirrors and then fed back on itself to cancel it out. And what you're left with is the area around the star that is going to be dark enough for you to be able to see. But the problem is it's all sort of done through optics and blocking and gratings that are done in the telescope itself. So it's not perfect. The star shade, what you do is you fly this thing out to about 10,000 kilometers away from your telescope, and it is this, looks like a big flower petal, right? Or
Mm-hmm.
flowers with
Mm-hmm.
with all the petals, and you've got this sphere in the middle, and you line up that sphere perfectly to cover the star, and then the planets will be seen in the gaps in between the petals. And the way the petals work is it sort of perfectly, it provides this sort of, I don't know what the term is, but like not a perfect line. It's like this broken up line, and that makes it easier to be able to reveal the planets around it. And that's why you make it in this shape of a flower with its petals. And those are the two technologies that have been proposed to block the light from the star to be able to reveal the planets. And if we can master this, and we're pretty close to mastering it now,
Mm-hmm.
especially with the coronagraphs that are here on Earth,
Right.
then we start to directly image exoplanets. And we no longer are concerned about having to use the radial velocity method or the transit method to be able to see planets. So it's so much better.
Yeah. Uh, do ask, can you explain further in detail how does taking mass away from the sun extend its life? It's again that convective fusion, but you can
Yeah.
elaborate on that
So
too.
the sun, I mean, our sun is a main sequence star and has really three layers to it. At the very middle is the core, where all of the hydrogen is being mashed into together, and that creates helium and releases energy. And then surrounding that is what's called the radiative layer. And the radiative layer is where the photons that are generated inside the sun hit this point where it's sort of like not enough pressure and temperature for fusion to happen anymore,
Mm-hmm.
but it is still like really hot. And so the photons have to jump from atom to atom. They jump around randomly until they finally make their way out of this radiative layer, and then they get into the convective layer. And then in the convective layer, blobs of solar material rise up like a lava lamp to the surface of the sun, and then energy is released, and then the thing is open to space, and it cools down, and the material falls down. So you've got these, just like the oceans, you've got these layers that are rising and falling in the sun.
Mm-hmm.
And the problem is that the sun is only going to last as long as there's fuel in the core. As soon as the fuel runs out in the core of the star, then the star dies, even though there's a ton of fuel in the radiative zone and a ton of fuel in the convective zone. With a smaller star like a red dwarf, they are, as you said, fully convective. So they
Mm-hmm.
don't have a radiative zone. They just have the core, and then they have the convective zone. And so this convective zone is dropping material down into the core, mixing it up, carrying it away. And so a red dwarf will, over its lifetime, use every part of its hydrogen, unlike stars like the sun, which run out of fuel in the core and then they die.
Yeah, yeah. And so and it's with those lower mass stars, they're just doing that hydrogen to helium. Those red
Right.
dwarf
There's more
stars.
complicated
Right.
kinds of fusion that go on in the higher mass stars. There's
Mm-hmm.
like the CNO cycle
Right.
on the heaviest mass stars, but it's really just about, like, if there is food, you know, if there's food trapped, if you're stuck in a cage and there's food outside the cage, you're still going to starve. And that's what happens with star. They've got the food that's inside the cage, and then there's the food that's outside the cage, and they eat all the food that's in the cage, and then they starve.
Yeah. So the bigger ones go through their food resource way faster. But they also, since having higher mass, they can work their way
Yeah, I
down the
mean,
periodic table more.
yeah, I mean, they are using up their fuel more quickly, but at the end
Mm-hmm.
of the day, it's just that they can only use a fraction of the fuel that's available to them. And so
Yeah.
it's those two things that happen together. The the sort of they sip their fuel at a slower rate, and they're able to use all the fuel that's available to them.
Yep. Someone actually did a great, yeah, it's add more wood to a fire, it burns faster. Despite having more wood to burn, the fire is hotter and burning it faster. That's actually pretty good.
Yeah, it is those two things coming together, right? That's
Mm-hmm.
all. Is that you've both got the fact that it's that it's burning faster, and that's why the biggest stars, they're gone in just a couple of million years. They burn
Yeah.
through all their fuel, and then they just detonate as a supernova.
Yeah, I think the silicon fusion is like what, like less than a day or something.
Yeah,
It's
when they get to the
crazy.
point that the final layers are getting, I mean, the star at this point is gigantic, right? The star
Yeah.
can be out to the orbit of Saturn
Mm-hmm.
when it's in these final stages. It's building up these layers inside its core of heavier and heavier elements. And when it gets to that silicon, yeah, it can be with several hours. And when it finally hits iron, it's instantaneous, and the
Yep.
whole star collapses in on itself at like 70% the speed of light,
Yeah.
and then kaboom,
Yep. Very,
detonate
very
and
violent.
create a black hole.
Mm-hmm. Um, so on that note, how much solar mass could be lost and still leave Earth viable for humans?
Well, uh, right now the sun is heating up, right, by a little bit every year. And
Mm-hmm.
so if we just let the sun do what it wants to do over the next 500 million to a billion years, the sun will be so hot that it will boil off all the oceans on the earth, and then that'll be that. So I think right now the sun is going to betray us.
Mm-hmm.
And so if you were to remove material from the sun, you could counteract this heating that's going on. You're essentially turning it. The more it tries to heat up, the more you force it to become more like a red dwarf, and you could probably match the amount that it's heating up with the amount that you'd be cooling. So in fact, removing material from the sun would be a one way to prevent its inevitable catastrophic betrayal.
Yeah. Someone asks, what's a little bit more exactly? Could it be adding to our warming condition here
No,
on Earth?
no. I mean, a little bit is like, I don't know. Let's say that it's going to increase by 50 degrees here on Earth over the next billion years.
Right.
That's 1 degree every tens of millions of years. So no, no, we're doing this all ourselves.
Yeah, and that's also a really good point, Nap Fan, is that the Earth would move closer if the sun had lost some of its mass.
Yes,
You would
which
have a
would
reorganization of the
right,
planets.
which would be a bit of a problem because then you'd be heating up again.
And but yeah, so and adding to the warming condition, no. But yeah, also as the sun's heating up, like it's becoming more luminous too. So
Right, right.
yeah,
I mean, what's actually happening, right, is you're getting, as the sun is burning through its hydrogen, helium is piling up in this region around the core, and that helium is helping heat up the sun and giving it more luminosity, and that's what's causing the sun to heat up. But people say, "Oh, we've got 5 billion years until the sun expands as a red giant." But in fact, we've really only got about 500 million to a billion.
oh yeah, no, Sean, I'm sorry. Yeah, correcting that. Yeah, you're right. So if it lost mass, we'd actually pull out further. We'd move away from it. That's some of the idea behind. And we've talked about this, Fraser, with when the sun, as it dies and starts to shed its outer layers. Well, I mean, it's in the active stages of dying, just like everything. But as it sheds its outer layers and loses that mass, that the Earth could potentially move away. So, Sean, you're right. Sorry, I got that confused.
Right. Yeah.
We can cut it and just this is not a live stream. Yeah,
Right.
no,
Yeah. No. Let's just go back. We'll edit that. We'll
we'll
redo
just
that
edit that.
question. Yeah. But I mean, there's a bunch of ideas on how you could actually, as the sun is heating up, there's ways that you could slowly move the Earth away from the sun, but it's a level of geoengineering.
Right.
Dr. Stickaholic is saying, Dr. Stickaholic is saying, I'm convinced we've messed up this wonderful ball of life and are close, if not past the point of no fixing or stabilizing. It's not true. The Earth doesn't care. Earth will be fine without us. So all we're doing is making it difficult for ourselves.
Yep.
Right? If we wipe ourselves out, a billion, or let's say 10 million years from now, you'd never know that we were gone, that we were here, or then we were gone.
Right.
So we don't need to save the Earth. We need to save humanity.
Yeah. It's not the rock will still be here.
Yeah.
That's one of the things that I talk about quite a bit. I get pretty annoyed when people say, save the planet, save the planet. And I'm like, no,
Yeah.
no, 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 no. The planet will still be here. Planet
Yeah.
does not care.
Yeah. Planet would
Uh,
shrug us off and move on.
yeah. So Daddy Cupcake asks, I heard that the moon was tidally locked in a very short time, like a week or a month. Is that true?
I've not heard that before. I
Me
can't
neither.
imagine that it would have happened that quickly.
Mm-mm.
Yeah.
Yeah, I would imagine usually tidal locking takes some time.
Yeah.
Uh,
Did you see a piece of news that just came out today? New research from Cassini that it looks like Saturn's rings are only 10 to 100 million years old.
yeah. Yeah, I was going to share that with everybody right
Yeah.
here.
Yeah.
Yeah, that Saturn's rings, they
That's
say
big news.
it's huge.
Yeah.
That indicates that this, yeah, right here, it says 10 million to 100 million years ago. So
Yeah.
Saturn didn't always have rings.
Yeah. Yeah. So now it's looking like a comet or some kind of dwarf planet or some kind of icy moon was torn up and Saturn got rings that like it does right now. And for the vast majority of the age of the solar system, Saturn didn't have any rings.
Yeah.
It's a mind bending because we just assume that what we see was what we've always seen, and astronomers have argued for a long time: are the rings young or are they old? But now it looks like the rings are very young.
Yeah, Zine, he just said that. Does this mean a big object was torn up by Saturn? Yeah,
Yeah,
yeah. And so they even say here that Saturn was formed again around the time that Earth was about 4.5 billion years ago. So this puts it, if the rings formed 10 million to 100 million years ago, those are pretty new rings.
yeah. And the part that I love about this is that these observations were made as Cassini was diving in between the rings and the planet. Like it was this its final act helped us get this close-up view of the rings to be able to make some of these most recent predictions.
Yeah, they dove through those rings, and that was
Yeah.
pretty scary. I know they were worried about it.
Yeah.
How old is our moon? Could it be related? So our moon, and we talked about this. You tell them about Thea.
Right. Well, the thinking goes that at some point, several billion years ago, like what, 3.5, 4 billion years ago, a Mars-sized object crashed into the Earth, and the debris was thrown out into space and coalesced and turned into the moon as we know it today.
Mm-hmm. And we were showing that. No, it's fine, doctors. We actually, I was showing this yesterday at the end of the stream. There's a video that captures how that worked really, really well. And I was showing everybody that. Must have been quite an impact. We can imagine a Mars-sized
Yeah.
object hitting Earth. That's pretty decent size.
Yeah.
But
Yeah.
we
You
were
can
rotating.
simulate it with Universe Sandbox.
Yeah. Which I got all my stuff for my new PC, so I can actually do Universe Sandbox Squared in time and very very soon here.
So Zoiku is just noting that somehow biodiversity loss and the extinction of the other species just overlooked as collateral damage. The planet is more than geology. I mean, the current biodiversity loss is tragic, right? I think I saw some research like insects have collapsed, 98% less insects in Puerto Rico than there was 30 years ago. Like it's a disaster that humanity is causing. But the reality is that 99.99 percent of species go extinct just here on Earth, because that's how Earth works, is
Hmm.
that species go extinct. It's just that we're making various species go extinct sooner than they would have. We are causing species to go extinct. But again, you look forward 10 million years without humanity, and there would be dramatic biodiversity across the planet. The um, the climate would have stabilized again to a place that the life is able to be happy. Like we are making Earth bad for us and definitely the life forms that are here right now. But we can't destroy the Earth. We can't ruin the environment for the long period of time.
Ooh,
So
now a
we
lot
need
of questions are coming in.
yeah.
So what was the delta 5 of that impact?
The Delta V, I don't know. Big.
And how true is panspermia?
For people who don't know what panspermia is, it's this idea that asteroids have smashed into Mars and Earth in the past, that rocks have been blown up into space, and then they have traveled from world to world, spreading life. And we know that each part of that journey is possible. You can smash an asteroid into Earth, and it will cause various objects to go into orbital velocities and escape velocities. We know that microbes can handle the environment of space for quite a while if they're protected in some way. We know that as objects are crashing into the atmospheres of other planets, that it remains cool enough inside for them to be able to survive the journey. So it's not a crazy idea to think that life could have gone from world to world. We have meteorites here on Earth that
Yeah.
came from Mars. So we know that this stuff is possible. Is it likely? We don't know, right? Right now, all we know is that there's life on Earth. If we go and do a better, more comprehensive survey of Mars, we find microbes there on Mars. We do genetic analysis to see if, do they even have genetic structure? Do they have DNA? Do they have RNA? Does it have the same chirality as the life here on Earth? And if it does, when did we share a common ancestor? So every single answer to that question would be fascinating. If it did share a common ancestor, that would be amazing, because it means that life can spread from world to world here in the solar system. There could be life all over the solar system now. If not, or if it's a completely different life form, then it tells us that life can form all the time in different varieties and different flavors, again, leading us to think that there's life throughout the universe. And if we don't find any life at all, then that makes it sound like life here on Earth is even more and more special.
Yeah, doesn't Emily Lakdawala, doesn't she have a bunch of, I thought she even had a Venus rock.
There are some rocks from Venus. There's ones from Dawn. There's
Yeah.
ones from Mars. There's ones from
She has a
various
really
other
cool rock
asteroids,
collection.
and definitely stuff from the moon. So
Yeah.
we have a lot of asteroids that they know came from, or meteorites that came from other worlds.
Yeah. Yeah, she has some cool stuff there. And yeah, it's also akin to like the way I say is like planets sneezing on asteroids or things
Yeah.
like that, and that's how that works.
One of the coolest ideas about this that I really like, and now we saw Oumuamua, right? We saw this asteroid that came through interstellar space from another star system, and that tells us, wow, not only can meteorites make it from world to world, but now material can make it from star to star. And so you think, with all of those impacts that have happened in the past, could we be trailing organic material, life, in this tail behind the solar system that other star systems could pass through? Is that a way that we could be spreading life from star to star throughout the entire Milky Way? If we find life on some other star system, are we related to them?
Right.
So this is, I've talked to a few scientists about this, and they say, well, the problem is that if this is happening, the trails that we're leaving are probably not that dense, and not, most likely other stars aren't going to necessarily be passing through them. At the same time, though, we're seeing a lot more of these estimates about things like Oumuamua, that there could be tens of thousands of interstellar objects passing through the solar system right now. Some have already been captured by Jupiter and other places. So I think that we're finding that we are more connected to the rest of the Milky Way than we ever thought before.
Hey, Bill Nash and Fez. There's another one that was really, really good there right underneath that. Where was it? How precise is the current, this was great. Twitch Machine asked this. How precise is the current prediction of sunbursts? If astronauts go out of Earth's magnetic field to the moon, this will be important, I guess.
Yeah, so the big problem, we get these solar flares. We see these events on the surface of the sun that are connected to coronal mass ejections, and in a heartbeat, it will dump out a lethal amount of lethal particles into space. And if if astronauts are outside of the Earth's protective magnetosphere and they go through this region, they'll get fried. They can receive a lethal dose from one of these really powerful solar storms. Like, think about things like the Carrington event and things like that. Yeah, it's deadly. So the question then is, do we have any way to predict this stuff? And we have a lot of telescopes that are now observing the sun. We've got SOHO, we've got oh man, the solar, oh, what is it called?
You're talking about the SDO?
SDO, yeah,
SDO?
SDO, Solar
Yeah.
Dynamic Observatory. There's a Japanese spacecraft, Hinode, that's doing that as well. So there have been much better, sort of a lot of really good research about trying to track activity on the sun and trying to match that with these various coronal mass ejections. And we're at a point now where astronomers can see a flare on the sun and know in what direction that flare was sent out into space, and know to give the astronauts some kind of warning to take preventative measures, precautions for when that solar storm arrives. Now, the kinds of precautions they can take are pretty hilarious,
Mm-hmm.
but still, they have a way to get some advanced warning to protect themselves. So we're at a point now where I think if astronauts are flying through space, we see a flare on the sun, we know the flare is directed towards the astronauts, we can give them a warning, they can try and minimize their radiation load as the flare and the solar storm passes them.
Yeah. There are these types of sun well, I'm trying to, Zulu's asking, are this types of sun radiation constant, or is it just like waves?
Well, I mean, the sun goes through various levels of activity. So there's the solar, goes from the solar minimum to the solar maximum. It's this 11-year cycle to go from one to the other. And it essentially matches every 11 years, the sun flips its magnetic field. Mm-hmm. So it goes from essentially its north pole being on one end to its south pole being on that end. And through that process, it goes through from its minimum to its maximum. And during the minimum, we see the least amount of activity on the sun, the least amount of sunspots, the least amount of coronal mass ejections. And that's about right now, actually. And then we see the solar maximum, where we see the most coronal mass ejections, the most flares, the most sunspots. And so in theory, you would want to go at times closer to the solar minimum, so that just luck-wise, you get less solar flares coming past the astronauts.
Yeah, and that can be really weird too, because the sun's kind of been weird. Like, if you notice with the solar eclipse in 2017, there was very few sunspots. Very few.
Yeah. And,
you know? Yeah.
So right now, the sun is very quiet. But we're still seeing some auroras, but it's not the good time to see auroras.
Right. Do we know what is driving the magnetic field reversal?
Well, the thinking is, like, the sun isn't solid, right? The sun is just a big blob of incandescent gas, a massive incandescent gas, as they might be giants say. And that the different regions on the sun rotate at different directions. And so you get to this situation where the magnetic field lines get tangled up and twisted, and will start to sort of shift. And then and they get to this point where there's pretty much no magnetic field lines over the entire, like, no giant ones. You just get localized ones, and then it flips over to the other way. And it's thought that something like that happens here on Earth as well. It just takes a much longer period of time. Mm-hmm. I mean, right now, someone's just mentioning in the comments, right? The magnetic north here on Earth is shifting fast right now. Canada just lost it. It's moved across the international date line, and now it's on its way to Siberia. So enjoy having the North Pole, Russians.
Yeah. And just to, so everybody's probably freaking out, thinking, what does this do to us? What is it, Fraser? What does it mean? What does it mean?
Yeah. Well, so this has happened many times. It seems to happen every few 100,000 years. The Earth's magnetic field flips over. So north is south, and south is north, and cats and dogs living together. So what is this going to cause? Nothing really. The flip seems to happen. We have seen these flips happen many times. It's amazing. You can see in lava flows, essentially, as the lava is flowing, the particles in the lava align with the magnetic field of the Earth. And you can have this situation where it's one way, and then a lava flow later, it's the other way. and there don't seem to be any mass extinction events that correspond to when these polar flips happen. So chances are it doesn't really cause any problems to us here on Earth. Although you might as well just throw away your compass.
Yeah.
It's not going to help you anymore.
It's not going to help you.
Yeah. And it might be there's an increased risk of cancer from
Right.
a less protective magnetosphere, things like that. But it doesn't
Right,
seem
radiation.
like we've really got the any big issues that happen to us.
Right. And I think let's see, that's the one you got there. How big would a solar flare have to be to really affect us here on Earth? We've had a few that have.
Yeah, the biggest flare that we know of that hit the Earth is this thing that was called the Carrington event. It happened in the 1800s, and so it's named after an astronomer who was watching the sun, and he saw this big bright flash on the sun, and he kind of like went, "Wow," and wrote down in his notes. And then a few days later, the people were able to see auroras at any part of the Earth. Down by the equator, they could see, and especially up in some of the northern latitudes, the huge amounts of energy was charged and pushed through telegraph lines, telegraph towers lit on fire. So it was a pretty dramatic event. And we have seen coronal mass ejections that powerful going in other directions in the past. We saw one as powerful or more powerful that just didn't come our way. So it's thought that we get one of these about every 500 years or so, something that is bad. And if one is that powerful and does hit the Earth, it's actually a really bad day for us here on Earth. It will do things like fry electronics, overload electrical systems, take satellites offline. Really, any time that you get various computers and electronics and cables connected to each other and you get excess electric charge jammed through these cables, you get electronics frying and giving out. And so we're kind of waiting. I mean, right now we're incredibly, with our interconnected society, with all of the amount that we rely on wires and electronics, we are really sitting ducks for the next big bad solar flare. The way we get around that is we come up with an electrical grid that isn't so interconnected. So instead of everybody having a big power station and all the power stations are all connected, you have things that are, say, smaller grids, solar panels with batteries that are connected to just a few homes. People have solar panels on the roof, things like that. So that way anyone, because right now it's just like the weakest link breaks the whole chain.
Right. Would it fry the whole Earth or just the part pointing at the sun?
Well, it depends, but what you get is the particles from the sun getting funneled down through the Earth's magnetic field lines, and so you can kind of get these increases in sort of charge moving through electronics almost anywhere on the Earth. But the part that's facing the sun that receives the brunt of the coronal mass ejection will see the worst of it.
Yeah. Someone said, ask him about crustal shift with the polar shift. Any chance of that?
No, not that I know of, unless this is something that I'm not knowing.
Let's see. I've looked for a few auroras outside of Toronto, but still very hard to see anything unless you go more north.
Well, so you need to put an Aurora app on your phone, especially, in Toronto, you can see auroras all the time. What's the one that I just got? I had an old Aurora app and it stopped getting updated. So now I've got, what is it called? Northern Lights? You should put the name of their app anywhere in their app. Man, this is terrible. This is the worst interface. Someone should do a good job of an Aurora app.
I know.
So
says the two computer science graduates on the stream right now.
And the person who built a successful moon phases app. Apps is a sucker's game. That's why I don't build apps anymore.
Yeah, it could be My Aurora forecast and alerts from Northern Lights and Borealis.
I think that's the one. Yeah.
Yeah.
Yeah. So it'll give you an alert when there's an aurora. It shows you where the auroras are happening around the Earth, and it'll send you an alert when an aurora that matches your requirements is happening in your part of the Earth. And you just get used to it. And so, for example, for me, I didn't know that an aurora was going to be happening. And then I got an alert on my phone and it said, oh, this could be aurora activity. And so I gathered up the family. We went to this beach that we have that faces north, and it was the most stunning sky show I've ever seen. The best auroras I've ever seen was happening above us, and it just blew our minds. And I wouldn't have known unless it was like, you have to be in it to win it, right? And so every time your aurora alert goes off, you have to go to this place that you have that faces north and hope to see it. In Toronto, you can absolutely see it. You just have to get away from the Toronto light pollution. But you should be able to find a place that's within an hour away from where you live to be able to see to the north. Even people who live farther south in places, like, you just have to have more extreme events that are happening. So if you live in, I don't know, Michigan, if you live in Colorado, wherever, New York, you still have a shot at seeing probably one or two auroras every year.
Yeah, no, we do. Kuden, we do. If you're in Kansas too.
Yeah, Kansas as well.
Yeah.
Northern Texas. Yeah, there's places that you can see auroras. You just have to the farther away you are from the northern latitudes, the just more organized you have to be about it. For the people who live in Iceland, they just walk outside and like, whoa, there's an aurora again. Yawn.
Going back inside. 52 degrees north or above should be very good for them.
Yeah.
So let's see.
Like, I think I'm at the 51st parallel where I am.
Yeah.
She's saying there's a shot. There's a shot.
There's a shot.
Yeah. Yeah. Put it on your phone. Put the app on your phone. When it tells you, calculate what is the minimum amount of aurora that you need to see in your location. When your phone freaks out, go try to see the aurora.
Yeah. So let's see. There was another question up here though too, and I don't want people. I have to kind of scroll up. Oh yeah, this is a good one. How do they succeed to determine normal natural polarity of the sun? By that I mean, how do they know that north is really a north?
I don't know. It's like I'm sure it's decided. Like, I mean, is there a way to know what is a north and a south? I mean, it wasn't the first. Someone had to decide that north is north on the first time that they figured out polarity of a magnet.
Yeah,
and then everyone has been basing it on that. Right?
Yeah. That's what I think too.
Yeah.
Yeah, someone just had to pretty much dictate that, hey, this is going to be north.
That it's like someone decided that up was up.
Right.
And everything else is down.
Someone says protons and electrons flow show the polarity.
Yeah, you can calculate. You can see like how material is moving on the sun. You can measure the polarity of the sun and know which is its north pole and which is its south pole. But like, how did the first one happen?
Right. And the sun's tilted about 7 degrees, I believe, too.
Is it?
Yeah.
Okay.
Yeah, the sun's tilted a little bit.
Compared to us?
Uh-huh. Yep. Is north and south the same as positive and negative?
No. The north, I mean, it's on a magnet, like on a bar magnet, there's like a plus, and that's north, and there's like a, like, we're getting way out into physics now. So, right. But the sun is like a big bar magnet.
Yeah.
One of them is its north. So the positive, and then one is the negative, one little minus sign on the bar magnet. One is the red one, and one is the black one.
One is the black one.
Yeah.
What about north and south WRT in the plane of the ecliptic?
Well, the plane of the ecliptic runs along the equator of the sun. And
right.
So sometimes the above, to the celestial north of the sun is the direction of its southern magnetic pole, and then other times it's the opposite. Every 11 years it flips.
In before monopole.
Yeah. Wait till we find a monopole. You could jumpstart your car with the sun. Yeah, you just have to harness that electricity.
Yep. So there was, I think that was around the. Might as well skip a step and dismiss all concerns with the heat death of the universe. That's what someone said earlier. Um, oh
That's
yeah,
great.
so
Dorian just
viewer
listened to
did
it.
ask. Mind explaining what you guys do? So yeah, I think viewer is new here.
Hmm.
So Fraser is the publisher of Universe Today and also the he is on the podcast of Astronomy Cast. He's also done a bunch of other things like Weekly Space Hangout and stuff. So he's all over the interwebs with good space news and bringing people information that's actually valuable and worth reading
Yeah, I've
and
been a
watching.
space journalist for almost 20 years now, reporting on the latest discoveries in space and astronomy.
Yeah, and he's a comp sci graduate just like myself.
Yeah, yeah. It doesn't use his computer science. Well, I use my computer science so that I can run a website.
Right. Right. And I'm a science communicator here on Twitch, and I have my friends on here that go and do things other places, and so we do things. He's usually on every Thursday. You know, granted he's not traveling or I'm not traveling, which seems to happen quite a bit in certain
Yep.
portions of the year. But we also do virtual star parties where we use. We have someone asked earlier if we have to pay to use the telescopes with OPT.
No, Oceanside Photon Telescope lets us use these telescopes for free.
Amazing people.
Yeah.
They
Yeah.
are very, very generous, and they allow us to use their observatories so that we can do this kind of stuff for you guys.
Yeah. Highly recommended. Check them out.
Yeah, and we have
You
a
want a
link for
telescope,
OPT.
go to
yeah,
OPT.
yeah, we have a link for all their stuff too.
Oh, there you go.
Yeah, yeah, and also they have a podcast too called
Mm-hmm.
Space Junk, which is really, really. I was on that, and that was fun.
Oh, well, yeah. I haven't been on their podcast yet. I've offered to be a guest. I'm sure it'll
Yeah.
happen at some point.
Oh yeah, yeah. And so yeah, Dustin and Ian, they both have joined us for the virtual star parties.
Virtual beer.
Yeah, exactly.
I wish.
Do we do? Yeah, that would be great. But yeah, so and you're going to be covering the lunar eclipse too. I want to talk about that before you go.
Sure, that's the plan. So, as I said, we've got a bit of a problem. I'm going to be rained out here on the West Coast, Los Angeles. Joshua Tree, the location of the main telescope that we use, is going to be rained out. Oceanside Photon Telescope is all going to be rained out. So there's a backup observatory in Texas that looks like it's going to have clear skies on Saturday and Sunday. So we're going to try doing some test runs on Saturday night with the telescope and see if I can make both to do the star party, but also for me to be able to get a nice live feed of the moon.
Mm-hmm.
And then we'll see what happens.
Yeah, it's been a while since. So yeah, and that's going to be great. And so if you're going to be doing that, the lunar eclipse, I'll probably wherever you're going to be doing that, I'll probably tune in with these guys, and watch wherever you're hosting that at. So just let me know so we can still join you to a degree. Did I hear Star Party? See, people are. Yeah, we're going to be working that out. And I believe Dustin said, I said we were thinking about doing one this Saturday, and he said, whatever observatory you guys need.
Yeah.
They're amazing at OPT. Very, very wonderful people.
Yeah, and his plan is to build many, many, many more of these things. So
Yeah.
I'm sure and the goal is, like, I know Dustin wants to get as many people as possible using telescopes as possible around the world. So
Ooh, they're showing off the ultra quad band narrow band filter that OPT just put up.
yeah, so they have one of those on the telescope, on the Texas telescope. But I don't know how to use it.
That's what you're learning right now.
Yeah. So it has a setting on it has a filter wheel that you can control remotely, and you can rotate it to I leave it on the full color, but you can switch it to that narrow band 4-channel at the same time.
Yeah. What time is it exactly for the star party? What time do you think?
Like, I think probably 8 Central Time.
Okay, so 7
on Saturday.
7 my time, and that'd be 6 your time. You're Pacific, right?
Yeah. Like it just depends on the skies getting dark.
Right.
At Texas, and I think they roll off the roof, and then that's when we can get access to it.
Yeah, so we'll do that. We'll plan on that. Um, how long have you guys been chatting on this stream?
Almost an hour.
Yeah, almost an hour. But as far as how long has he been a guest on here? Gosh, almost a year.
Really? There
So
you go.
come
Several
March.
months.
Come March, it will be.
Okay.
Wow.
Yeah, you. How did this all happen? Oh, that's right. You would host Pamela on a regular basis,
Yeah, and then we had the front page.
and then you
Remember
had the
we
front
had
page, and you were looking for more guests. Yeah.
yeah Fraser helped get us Dr. Katie Mack, Emily Lakdawala. She was amazing. Phil Plate came on here.
Yeah.
We even got Skeptic's Guide to the Universe. Bob Novella, he came on here. It was brutal. It was tough, but it was amazing. It was a good run.
That was fun.
Yeah. So dark 8 p.m. Yeah, 8 p.m. Central. I think that's a good time to shoot for, guys. And
Yeah.
don't worry, I'll tweet that out. And another thing that we can talk about real quick, because we need to start talking about this more. I need to start talking about it more. Is the All Stars party?
Mm-hmm.
We have the All Stars party.
Yeah. So we're going to be meeting up in person, IRL, in June, end of June 2019, and we're going to be staying at this luxury resort in Joshua Tree, close to the park. And then we're going to, over the course of 3 nights, I think, 4 nights, we're going to be setting up really fancy telescopes, and we're just going to be observing the night sky and
Yep.
teaching you how to use telescopes and just hanging out and just being. We're going to do talks, and we're going to go on adventures, and it's going to be fun for a nominal fee. Yes, it is. There is a fee.
Mm-hmm. There is a fee.
Yeah.
And are you from Canada, Fraser? How did you know?
Yeah.
How did you know?
Oot and a boot.
Wait, say lava.
Lava.
Lava. You say lava.
Yeah. Yeah.
Sorry, no.
The problem is my wife is American, and so she thinks it's hilarious. But I've actually changed some of the way I say some of this stuff now, because I don't know. I don't know what it is, like almost like self-conscious about my hilarious Canadian accent.
It's okay. So. I give Fingrush all of the crap about being from Philly and how he says things. It's really great.
Yeah.
So even within the U.S., we still all kind of make fun of each other too.
Yeah.
It's real fun. Can we get a link to the All Stars party? Yeah. If you do the command All Stars, it will be right there, and you guys can check that out. And again, it's going to be Paul. You guys know Dr. Paul. Dr. Pamela, you guys know as well, and Fraser, and then Michael Gaudier, he'll be there as well, or John Michael Gaudier.
Yeah, you should have John on. Have you had John on your show yet?
I haven't, but isn't he talk a lot about like EM drives and stuff? And I feel like I just fall so far behind when we start getting into.
No way. No, he
No?
loves to talk about Tabby Star.
Oh God, does he say Dyson spheres though?
Does he techno signatures?
With Tabby
a lot
Star?
of more planetary migration. No, it's all the same kind of stuff. He'll be great.
Oh, so he wouldn't say that it's a Dyson sphere with Tabby Star.
No.
Okay.
No, he's on this side of the line of of science. No problem.
Bill says, please.
You can trust him, but the point is, like, he like Isaac Arthur kind of specialize in some of the more futuristic, cool technologies, and talking about, I think, one of his favorite topics is just the search for extraterrestrials via, radio transmissions, various other methods of searching for evidence of aliens out there. So no,
they should get him on here.
Yeah,
that would be good. Everybody would love that
as a guest.
Yeah, Bill Nash says, please, God, let's talk stellar drives.
There you go. Yeah, he's a science fiction author. It's so funny. So, like, he originally was a sci-fi author, but he has a science background in his knowledge. But he started doing YouTube to get more. You should play some of his stuff, but doing more YouTube to be able to help promote his science fiction. And now this is like he's become a science YouTuber, which is fun.
Ooh,
so
I should check out his stuff.
Flipped around now, and he's so busy just doing the videos and interacting with his community that he's kind of taking off. So
Yeah.
He gets way more views on his videos than I do. So yeah, you should totally get him.
Well, it's yeah. We should check it
I will
out.
introduce you guys.
Awesome. Okay.
And that way, when you actually meet him at the All-Stars party, you'll have some history already.
Yeah, that'd be great. But it is
Now,
2 though. Do you have
what's
to
that?
get going? It is at the top of the hour.
Yeah, so I've got to run. But before I do, I just want to remind everybody that Sky's only got 5 out of her 15 sub goal here. And, this is the time, right? We talk about this every week. The fact that Sky is spending hours every day trying to sort of carve out this tiny little chunk of Twitch, which is just a bunch of people playing video games and doing ASMR. And she's trying to help explain and educate and spread the love of science. And you get what you want. You get what you pay for here, right? If we can show and demonstrate that these are the kinds of channels that we want to subscribe to, then we can try and have some ways to be able to get more science. Tell Twitch that this is the kind of content that we want to have here on the channel. So just take a second. If you have already subscribed to Sky, then why not find some person who is clearly part of the community and gift them a donation. Get them to try it out for a month. So let's get her to hit her 15 subs for the day as quickly as possible.
Thank you so much for that.
No problem.
Can you subscribe on mobile? I think if you do sub, I think that might work. Yeah. Maybe. We'll see. Well, thank you so much. And I'll see you Saturday. And already right now, Ian's messaging me. So,
good.
Yeah, so we'll set that up. And I'll talk to you soon.
Okay, great.
All right. Take care.
All right.
Bye.